So for our final panel today, we're going to take you into the future, sometimes really far into the future. And with that, I wanted to introduce our set of panelists, starting from my very right, Mouse McCoy. He is a director, former professional motocross racer. That ties into his job, which is his company, rather, Hackrod, which, and I need to read this off to get it right. So it was the first company to design the first virtual reality AI designed and engineered 3D printed car. That's pretty cool. Brian Anthony, director of MIT's Master of Engineering in Manufacturing program, actually won an Emmy for broadcast technical innovation. So dug that fact up online, wasn't expecting that. And finally, at the very end, we have Dave Lavery. This is NASA's program executive for solar system exploration. And what does that mean? Well, his team built the rover that actually found water on Mars. So really forward-looking panel. Thumbs up there from Mouse. And maybe we'll start, Mouse, I wanted to start with you because your business really encapsulates a lot of what we've been talking about today. You're partnered with Siemens. You're utilizing a lot of this technology that we're talking about, whether it's 3D printing, AI, robotics. And I guess I wanted to ask, how do you think about technology? How do you think about moving forward today?
Well, I think we can use those, AI, blah, blah, blah. But I think really what we need to look at is everything's going to roll into our vision of the future, which is the gamification of engineering, design, and manufacturing. I think to hit this right out, we're talking about education. What do kids do instead of learning right now? They play video games. This generation expects everything to work like a video game and a social network. So we think the future is going to look a lot like the gamification of engineering and manufacturing.
You actually referenced a movie when we were talking earlier.
Well, yeah, I'm a movie director, so I live in that visual kind of crazy world, but I think a lot of people have probably seen Ready Player One. Well, if you think about a future immersive world, well, no, everyone just looked at entertainment and play and running around, but that's how manufacturing and engineering design is going to happen. And it's going to be supported by AI, and it's going to be connected to a wide range of distributed manufacturing suppliers and entrepreneurs. So that's really the best way to visualize it is Ready Player One for manufacturing.
Dave, where you're coming from, you're creating kind of on a smaller scale. You're creating one robot, one piece that's going to be used and really needs to work. So you're not doing the sort of vast manufacturing, making 5, 10,000 million of these items. Can some of these technologies we're talking about, maybe even something Mouse has mentioned here, can that be used within your own line of work, do you think? Or?
Yeah, I think they definitely can. As you mentioned, we're not manufacturing tens of thousands of anything. We're not General Motors. For us, mass production is 5. If we're extraordinarily lucky, maybe 6 of something. And that's, I send 2 rovers to Mars. I've got the 2 flight units, 2 flight spares, and 1 or 2 engineering units. And so we approach the fabrication process in a different manner, perhaps, than a lot of people will. But I look at the front end of that process and the actual design process and what happens there. And there's a lot of similarities. And we're certainly in the mode of taking advantage of every tool that's out there that we possibly can to make that part of the process as efficient and effective as possible, mostly because we get pretty much one shot at it. When we build something, we don't get to iterate. We launch it. It's, on average, in the case of the rovers, 315 million miles away. A service call is out of the question. I noticed on the previous panel they mentioned, hey, every time we send a truck out on a service call, it's $500. For us, sending a truck on a service call is $5.5 billion, and it's just not going to happen. So I look at, what can I do on the front end, the design process, to guarantee that the thing I fly is as error-free and as iteration-free as humanly possible. So we'll look at a lot of different tools to do that. Again, Ben Reed was just up here from Microsoft talking about what they've done with the HoloLens. We actually work closely with Microsoft on a project that was designed to take the Mars experience and bring it to Earth and allow our science teams to understand the context of the surface of Mars. We actually have a case where I actually start my morning every day. First 10 minutes of my day, I walk into my office, I put on a headset, and I walk on Mars based on the photographs that came down from the rover last night. And by doing that, I get an innate understanding of Mars as a place that allows me to infuse that knowledge into the design process for the next rover, the next generation mission, things like that. And so we'll take advantage of those tools wherever we can, and then sort of as a hard piece of that, using that same tool, that same knowledge to allow collaborative design to happen where I may have some of the best engineers in the world, or in our case, off the world, working collaboratively together on a project to design next generation spacecraft, but without having to co-locate them, to instead use these tools with augmented reality and virtual reality to look at a virtual model of the thing that we're building and have that knowledge and have both the representation of the model as well as representations of my collaborators all in the same virtual space at the same time to go through the design process, to make our design iterations there with a virtual thing, and then move on. And the most extreme version of that is we actually have our science teams meeting on the surface of Mars every now and then to do that collaboration.
I want to bring you in here, Brian, because you are not only doing some of this really cool stuff, you're training people to do this. Can you talk a bit about maybe how you do that? How do you prepare people for this world? How do you prepare students and young professionals for this kind of a world where this technology exists and they have to develop it?
Well, you can't be a professional in manufacturing without partnering with people that are actually doing manufacturing. So I think some of the critical things that we do, both in understanding current technology and how it's deployed and developing new technology, is to partner with companies, either in developing the research or developing the things that students are doing for their research. But for example, in the MEng program that I direct, we'll put a group of 3 students into a company to have a 6 to 9 month activity where they're really focused on a problem that's in the line of fire of the company and potentially applying new technologies, new digital technologies to whether it be their current products or new product introduction, and really working closely together in the academic education process to understand what are your challenges and bringing that need back to the mothership, back to the university environment when they're still in the ivory tower, and doing that collaboratively. And then once you have that opportunity to solve immediate problems and you've established that relationship as you're looking towards the next generation of challenges, whether it be a new process where we need to understand in situ what are the mechanical and geometry properties of a machine so that you can superimpose a set of virtual reality interactions with it. And how do you do that in a very robust way to understand the subtleties that you need to deploy such a technology? You can't do that in the lab. You need to be out in the manufacturing environment, actually seeing it and experiencing it.
Well, when we were speaking earlier, you actually you use this line, and it still sticks with me, is the manufacturing floor is one of the best data sources, and using that. And on the other hand, we have Mouse who's saying, well, actually, it's going to be more in the digital space. Is there room for these two ideas to sort of coexist?
Yeah, I'd like to hit on something that just hit me that's really cool. So the ethos and the lens that we looked at in founding our vision was 3 kids in a garage. And, you know, the American hot rod ethos of that can-do spirit, individuality, artistry. But there was always this huge barrier to entry. Those 3 kids in a garage in the industrial space, they didn't have access to the same tools as NASA. They didn't have access to 1,000 engineers at Ford. But now I'm working with the same technology that NASA is. We're sitting in our shop in full photoreal VR and letting AI engineering solve problems that used to take 1,000 engineers. So what that means is the barriers to entry for kids looking to get into heavy industry and to start industrial companies is flattening. It's flattening the way it did in the digital space overall. So to stand here and realize that a startup is working with the same technology as NASA, I think that's really relevant of where we're headed overall. And you know, one of the things why we're so excited to be working with Siemens is they're covering the entire spectrum. And we've talked a lot about the digital twin. So if you have a digital twin that's a really heavy, smart file, and the mirror of that now becomes the virtual twin, you're going to be able to interact and play. But if that wants to be into commerce and you want to buy that product that 3 kids in a garage design, and it can be a motorcycle or a car, that's going to be able to go into effect right away. And this is going to really change the landscape and open up what the potential I think we all think for Industry 4.0.
What about personalization then? Because if you are, like right now, able to create your own vehicle to whatever specifications you have, or maybe it could be applied to other things. I don't know if that's something you guys are looking at right now, but
I think the concept of the consumer becoming creator of things in their life and not just taking what a big corporation says, here's what you get, take it. You look at Nike ID, kids, it's a multi-billion, it's exploding with kids making their own sneakers, and my Adidas. That's just going to scale up. Next thing will be bicycles and electric skateboards and motorcycles, all the way up to full-scale automotive and probably to flying cars. Those barriers of entry are going to flatten. So I just think it's such an exciting time right now for kids.
How do you think that'll impact manufacturing as a whole, though? Because right now we're on a very specific kind of when you're.
Okay, so I want to hit one thing. A lot of people that
get Brian in here.
So, a lot of people that have followed us for a while know that, oh yeah, you guys are really big into 3D printing. Well, that was because there was a problem to solve, and we call it the last mile. Right now, the digital thread in 4.0 runs into a brick wall when you got to go back to manufacturing at any kind of scale, and you get into the tooling model. The tooling model requires you to build massive lots of things, and there's compromise, and it changes the economics and kills the business models. So we said, all right, for this gamification to work, the last mile of large-scale, validated additive manufacturing had to be solved. So this year, the big bang has happened. We've just, right now, printed a full-scale automotive chassis that's validated and certified to aerospace-grade specs. Our CTO was a former head of advanced manufacturing and materials at Lockheed Martin Skunk Works and Space Systems. So we're now validating and building large-scale metal and carbon composite objects that can replace tooling for an on-demand economy. So once again, this is a big deal this year.
And let's broaden that out. Brian, how do you see that trend, that movement, filtering down into the broader manufacturing industry? Are we going to start maybe seeing other companies pursuing this? Does it mean rethinking what a factory looks like, and if so, how?
Well, I think there are a couple answers here. So technologies where you're doing additive manufacturing, 3D printing, they're at a price point now where you actually can start to imagine doing production scale activities. But there are other technologies that you would find, say, in the semiconductor industry, where those price points to build a fab, if you wanted to make a new sensor, a new camera, those have not been, you don't have democratized access to such technology. You can't buy those off the shelf yet. So one of the things that we've done at MIT, we just launched a 200,000 square foot nano fabrication, nano characterization facility called MIT Nano.
What is that?
MIT Nano is a shared resource for all of campus, but actually not just campus, for industry partners, where we really want to allow people that are interested in either fabricating at the nanoscale or characterizing at the nanoscale to use the multi-million-dollar technology that we've been able to centrally locate on campus, but to have an opportunity for small companies, whether they're just spinning out of MIT or in the ecosystem, to be able to come and use that, because you can't buy those things. Those aren't you don't have the additive manufacturing versions of those yet, and it's going to be years for that. But new technology that is for new sensors, new cameras, new physiological monitors, new things where you can do roll-to-roll printing of sensors that you can slap onto the outside of your piece of machinery. You can't make those yet in a way that does not require the clean space such that MIT Nano provides. And so really looking at how do we bring in the academic environment, now not just doing our research and our education, but allowing small companies to come in or big companies to come in and use a massive centrally located set of resources that are going to really allow us to innovate in a very novel manufacturing technology that would previously only be at the purview of Siemens and Analog Devices, companies that have access to the high-end fabs.
What's going on at NASA?
I think one of the things that we're focusing on, well, a lot of the efforts that we just talked about are going on at NASA as well. But the other piece of the pipeline that we're also really paying a lot of attention to is, in addition to the new emerging technologies that are being utilized in all these procedures, what about the people that actually have to operate them, and where do you get those from? And that's actually been a big focus of ours for quite a while. Before I was in my current job, I used to run something called the NASA Robotics Technology Program, which was looking at advanced robotics research and technology that would then be used in flight systems in the next generations. And at the time, we recognized that every year as I went through our research proposals, it was the same group of faces over and over and over that were getting slightly older and slightly grayer, and nobody else in the pipeline behind them. And we realized we had a real problem there in that technology. About the same time, thoroughly by accident, we stumbled across a robotics competition program for students that we sort of recognized and said, these high school kids who are trying to build robots to go and compete out on a game field, they're exactly the sort of people that I need to fill my pipeline 5 years from now as my aging researchers finally get to the end of their career and start retiring out. And so we got very involved with this, and there's a lot of sort of the details of how that all happened that we can talk about. But the net result was I can now go, for example, to the Automation, Robotics, and Simulation Lab down at Johnson Space Center in Houston. And as I walk around the lab and talk to people that are there, 70% of my current employees there are all alumni or mentors or both from this one particular robotics competition program in which we participate. So that's been a great way to get folks involved in what we're doing, interested in what we're doing. And then here's a couple of numbers that go along with that. Because a lot of these programs are out there, and I always sort of worry about, you know, the stats that the programs will give you. Are they real? Are they sort of the instantaneous flash of excitement because I'm building a robot and I'm doing something with it right now? And what really happens long term on some of these things? And by the way, just as a quick diversion, this particular program, though, we work now with FIRST Robotics, with VEX Robotics, and with Botpol, if you've heard of any of those, as ways to get high school and earlier students excited and inspired, in this particular case, not just about robotics, but about science, technology, engineering, math, the STEM buzzword that everyone knows overall. And it seems to be working, but we wanted to know how well it was working. So we went and looked at students who had been involved with one of our teams at least 10 years ago, and what were they doing now, 10 years after the fact, and compared it to national averages. At the time we did an internal look, according to the Bureau of Labor Statistics, 4.37% of the working adult population in the United States, 137 million people, were involved in a science, technology, engineering, math, or architecture-related career as their current job function. We thought if 10 years after being involved with us on one of these teams, if it was twice the national average, that would be statistically significant. 3 times the national average, we would be ecstatic. 10 years after these students have worked with us on one of these robot competition teams, we found out 58% of them were actively involved as their current job function in some field or some job related to science, technology, engineering, math, 13 times the national average. Now, be really careful not to say there's causality there. I can't show that, but I can show the correlation. If nothing else, as I'm searching for future robotics engineers or engineers in general to build my spacecraft or to build an automobile, to design a bridge, to design a blender for my kitchen, whatever, I know where to get them. These programs that are actively working with students, not necessarily to educate, but to inspire them about getting involved with engineering and mathematics and science, are great ways to figure out who your future employees should be, or certainly where you can get them. And that's one of the paths that we're following very intently.
So it sounds like companies really need to start thinking about this with kids from a very, very early age.
We actually, I'll throw one more thing in there. This goes back to a discussion that I had with one of the executives at GM a number of years ago. And it became a really interesting data point for me. With the amount of money that he spent recruiting one fresh out new hire engineer, by the time he did the recruiting calls, the relocation, the sign-in bonus, and everything else, to recruit and hire one brand new engineer into the company, he could fund a FIRST Robotics team for 4 years. At the end of that, he had 80 high school graduates who knew his company. He knew all of them. They were going off to college in some STEM-related career path. He followed them all the way through college. They came and worked for him during the summer as interns in a lot of cases, or as paid summer positions. And when they graduated from college, some of them will drop off, but he could guarantee he had about 15 out of that 80 that were ready to come and walk in the door, who already, as far as he was concerned, were known quantities, were familiar with him, and actively wanted to work for him, and he could cherry pick the best, all for the cost of hiring one brand new engineer. And so economically, in terms of just HR and recruiting, it made a whole lot of sense. but also they walked in the door not as a brand new hire, but again, as somebody who knew his company. They already knew the procedures, they knew the tools, they knew the people, so he effectively was hiring somebody at their second year of career path in the company.
I'd like to expand on that, because if you had a need and you did a call that went out, and think about being in an immersive, physics-based, 3D visualization world, kids will build solutions, whether it's the next lunar rover, and they will be able to present that, their version of it, running through simulation, completely digitized, so digitalization on that factor, and you're going to say, wow, that's an amazing idea, and it might be a group of kids that didn't even go to college. I just want to flag that, and they built a solution that nobody thought about, and you're able to observe it in full photoreal scale, watch it perform its operation with accuracy and simulation, and they're going to get the job. And before, those kids would have never, ever even gotten the door because nobody paid for them to go to MIT, with all due respect. Or you bring up GM right now, and so most of the kids that end up going and design students, they come from affluence. They go to Art Center, they go to these schools, and they come out with these really great-looking portfolios, and they get the opportunity to go to GM, where it might be some kids down the street in a garage that have the best new design, they don't even get looked at. And then those kids from Art Center, they go into GM, and then they get to work on a door handle for 8 years. And then they go through the hierarchical structure to come be a senior designer, and then maybe you might get a crack at designing a car. I think that needs to go away.
So I want to balance that, because I think there's, by the way, most people that come to MIT don't pay much to come to MIT.
Bad example, USC.
But so I think there's, if you look at what's really changed, it's this phenomenal access to technology. Whether it be sort of the games that students are native with, or the 3D printing that students are now native with. Making is something that's not manufacturing, but you've been exposed to the fact that I can make something with my hands. So one of the things that sort of we've been very concerned with is how do we make production quality hardware, physical hardware that you can interact with, and get that down to the K through 12 community college level. So we've made these tabletop extrusion kits. Actually, this is something that I know some of the folks here at Siemens were involved with. A couple of years ago, we taught a professional education class, and we brought in plant managers from Arconic, from around the world, and brought them into MIT for a 2-week program. And we taught them smart manufacturing concepts on top of this little extruder kit that makes production quality fiber. But using that so you can see what a run chart looks like. You can see what why temperature and speed of all these extruding processes are important, and actually have that physical, tangible piece. In addition to all the data that's coming out of the system, piping that up into the software and tools that Siemens provides, that's okay, and now I can understand how to balance this. I see this real piece of hardware. I see all the CAD models for how I can design it and improve it. I see the data, and now I can get into those feedback loops, because ultimately it's connecting all those pieces. It's not just I want to see the VR piece or I want to see the data. I have the combination of the physical and the digital, and that rapid feedback between the two, and the proliferation and availability of being able to tangibly interact with something and virtually interact with something, and getting that out into the K through 12 community colleges. I think that's really where we have the largest impact for the HR dollar, and for transforming what we can do for new technology.
So schools starting to think a lot more like the private sector, or at least partnering a lot with the private sector as well. Is that something at NASA that you guys are doing as well, or is expanding rather? Because I know you talked about this program that you're very heavily involved in. Is that a trend you're seeing as well?
Yeah, I mean, we started out working with some of these programs. We've actually been involved. This is 24 years now. We've been specifically involved with some of these robot competition programs that are targeting originally high school students, but now getting much, much earlier in the process. And it's grown from working with one team 24 years ago to where we're now sponsoring in various different levels, several hundred teams around the country, and have direct contact through these programs with our employees who are acting as mentors with these teams in one facet or another, with over 10,000 students per year. And we have shifted our focus a little bit. I mean, at first and still today, a big part of why we're doing this is because I'm trying to feed my pipeline of future engineers and future employees. But I've expanded sort of beyond the original vision of my specific robotics technology program needs 5 new robotics PhDs in 3 years, to yes, I do that, but I'm also trying to increase the supply of STEM aware and STEM conversant people in the public in general. Yes, if they come to work for us, fantastic, that fulfills my vision. They go to work with one of our contractors who feed into us. That's great, that's a success too. If they go out in the general public and rather than become an engineer, they become a writer or a lawyer or a baker, but they understand science, they appreciate it, they are conversant with it, we count that as a success because all of that feeds toward what we're trying to achieve as an organization.
When people are looking for where to work, it's not that hard, I would imagine, for them to work or want to work for NASA or Hackrod or Siemens or another large company. I guess, what kind of advice would you give to companies that don't have that brand name recognition or maybe smaller manufacturers? Because we're talking about a lot of interesting ideas that might not be fully applicable to all manufacturers, or maybe it is. Maybe it is.
Actually, let me just very quickly challenge something you just said. We're working with students going all the way down into 5th and 6th grade. We had one case of a student who was exceptionally gifted at developing websites. He developed a website for his robotics team. It was so good that we had the folks at NASA Ames Research Center out in Mountain View in Silicon Valley say, would you like to come and work with us for the summer? He was a high school junior at the time. Would you like to come and work with us over the summer? Basically working with the folks who really developed and program and managed the true backbone of the worldwide internet. And his response was, well, what does it pay? Okay, well, we are a government organization, so it's a GS2 government pay scale for summer employees. And he said, I'd really like to, but I can't afford the pay cut. As a high school junior, he's telling me this. And so, yeah, people are interested in working for NASA, but there are offsetting factors that we get hit with all the time, pay being one of them, access to various different technologies being another. And so we're fighting for people and employees and the really good engineering staff, just like everybody else does.
And I think coupled to that, I mean, young people or people of any age, but I think certainly young people want to see fewer barriers. It needs to be more of a meritocracy, that if I'm in a big organization that I don't necessarily, if I'm phenomenal and I prove myself in developing this wonderful new piece of technology, that I can take leaps and have a lot of mobility and opportunity based on my skills. I don't necessarily have to work my way up through a ladder.
What's been your experience so far, Miles, at your company?
I think that kids should be thinking about doing it for themselves, and the ability to be entrepreneurial in the industrial space. Once again, I think I said it before, that barrier is going to be eliminated. So think about building your own company. If you really look at Industry 4.0, small enterprise is actually going to have the advantage over large corporations. I think large corporations aren't going to be able to turn. They have too many legacy systems. They have too much legacy in their management structure. You have too many people that don't want to take chances with the company because they're 3 years from their pension and they don't want to take a risk. But small enterprise is going to have the technological capabilities to outperform the large organizations. And it's going to be interesting to see what happens in defense. I just want to throw that out there right now, because you got the big primes that control everything. And I've been having this conversation with some senior officials in the defense industry saying the bad guys over here are going to be able to outperform the legacy contractors in the near future. So I think everybody's got to wake up right now. They got to wake up.
Yeah. But I think there's a balance there, because I think when I certainly agree, you're the newer products, the new technologies, that's going to be the purview of the people that are looking around and saying, what's next? I'm not encumbered by what's come before. But if I hit the grand slam and I say, oh, I have a demand of 1 million units per year, I'm going to do a what? How do I scale that? So I think there's certainly a role for the big company, sort of that large scale production that requires sort of that focused, okay, I know what I'm doing it very well repeatedly, as opposed to, okay, I have some really new things that I need to do the skunk works and bringing people together that are sort of looking all over the place. But once I've sort of focused on making 1 million, 2 million a year, that requires a different set of skills, a different way of of looking at the world and sort of a different incentive structure, I think.
I agree. I'll give a case study. The motorcycle industry, still controlled by a few big major companies. A lot of my friends are the coolest motorcycle designers around. They hand draw and they sit for 2 months pounding out a really great bike, and they make one bike. They go to a show, people love it, they sell it for a good amount of money, and that's great. Those same couple, 3 guys, designers, they could roll their bike in, quickly scan it, upload it. We build a digital twin. They have huge social media followings. They post out, hey, everybody love this bike. We're going to do a run of one. Who wants one? They get 100 pre-orders, just 100. But now they don't have to go capitalize, start up, build a factory, do all of that. It's an on-demand model. They can fulfill it. We can print. And I'm using a lot size of 100, so it's, to your point, it's not 1 million. It's not scale like that. But 3 kids who are designers can become a motorcycle company overnight with no risk.
I want to ask you guys a lot more questions. We've run out of time, but we could have taken this a lot of different ways. Thank you so much for your time.
I
Mouse is
can't
never
not
done.
say this.
Never
I cannot
done.
say this. Okay. With all due respect, and I do respect him because I know this is Bloomberg's public, to Mr. Musk. So he shot his car somewhere. He put his Tesla thing and shot on a rocket, and he's talking about Mars. You guys have been driving a robotic, autonomous car on Mars for 30 years?
The current one that we're actually waiting to wake up right now from the dust storm has been going for 14 years, and that was originally designed for a 90-day mission.
Right. So everybody thought, oh, wow, he threw that car into space. Wasn't that cool? I was like, you've been driving cars on Mars for a long time. I just had to say it. I can't.
He did make quite a profit yesterday. Last night the earnings came out, so that has pretty good implications for manufacturers. Thank you so much.
Thank you.